Well, good morning, everybody. It is 7 o'clock, so we are going to start our last virtual breakfast for the year. I would like to welcome everyone. I'm Jennifer Benson, PEP's Executive Director. A couple of best practices for the meeting. Please keep your microphone on mute to prevent any background noise or feedback. After we get everything started, if your camera is on, unless you're going to be speaking or asking questions, we appreciate you turning off your camera to make sure we have great connections. During the presentation, if you have any questions, go ahead and submit them through chat. And then at the end of it, I will manage that and get you all to talk about your questions and whatnot. Before I turn the meeting over to Helen, I do want to mention just a couple of announcements. The first thing is I want to share with you our truck bed trash can campaign. This is something we kicked off about a month and a half ago. Trash blows, stow it. We had gotten a grant, a small grant with the Dog River Clearwater Revival Organization and the NEP to work on roadside litter. Our portion of this is to get business engaged in helping educate their employees who drive pickup trucks, as well as employees who have their own fleet of trucks, to make sure that they are aware that if you throw trash in the back of your pickup truck, it'll blow out unless it's secure. So we have a great website that gives information to businesses about how they can engage their employees. There's also messaging for individuals. There's a pledge for you to take that you will secure your trash. And also, we have a great digital package to share with businesses to use for information and visuals for through their newsletters or their company intranets or podcasts or whatever the company does. So that is one thing that I wanted to mention. The other thing I want to mention is that on December 3rd, we have our education seminar coming up. This is our 5th year doing this. This year, the topic is, were you ready for a global pandemic? I don't think anybody was, honestly, but impacts to business operations, contracts, and people. So CEU credits are available for people who self-report, particularly engineering and others. We have some great speakers that are going to talk about what they implemented, what kind of technology they discovered to use to make this a better situation for their company, how employees were engaged. But this is going to be interactive. So we really want people thinking about the questions and coming with questions to ask our great list of speakers, as you can see here. And you'll be getting more information about this. It's free. It's open to the public. Share it far and wide. But you do have to register to get the link, just to try and prevent, getting hacked, which has happened. So the only other comment I'll make now, and this is, I don't have a slide for this, but if you recall, we have a science and technology scholarship program. This is for people who are in college or graduate school already, not for kids in high school, but this are people who are studying the natural sciences, environmental science, and all engineering disciplines. It's an annual award of $2,500 or a one-time award for $2,500. Also, well, I just got a note that says I've got bad network quality, so I hope I'm not freezing up. I hope you're able to hear me, and I'm sorry if you cannot. But anyway, the scholarship opens December 1. And this is for all of your employees based in the Alabama Gulf Coast, Pascagoula to Florida, the PEP area. So if you have an employee who's going back to school, let them apply for the scholarship or encourage them to apply for the scholarship. If they have dependents, kids who are in college or grad school, same for them. They are eligible. It is for PEP members that this scholarship program has been set up. So all of your employees, if they meet the criteria, are eligible. And we need your help sharing that with everyone. So we will be sending information about that as well. December 1 closes March 15th. So there's plenty of time. And so those are the announcements that I wanted to make sure all of our PEP members were aware of. Again, thank you all for being here today. Thank you. I know this is an early meeting, even though we're not gathering and networking. But now I'd like to turn it over to Helen Bush, with Avonic, who is also our Secretary Treasurer of PEP's Board of Directors, and she's going to introduce you to our fantastic sponsor. Helen?
All right. Hey, good morning, everybody. I'm very pleased to introduce our sponsor this morning, Complete Environmental Risk Management, or CERM. CERM has been a member of PEP since 2017, and they have produced a short video to share with us today. But first, I would like to introduce Dr. Terrell Gibbs, PE, CERM's Environmental Business Group leader, who will make some brief remarks and introduce their video.
Fantastic. Thank you, Helen. Yes, good morning. My name is Terrell Gibbs, and I'm the Environmental Business Group Manager for Corporate Environmental Risk Management, better known as CERM. It is our esteemed pleasure to sponsor the November Partners for Environmental Progress breakfast virtual meeting. CERM is a full-service environmental consulting firm specializing in providing custom solutions to energy, environmental facilities, federal transportation, and water resources clients throughout the southeastern United States. Headquartered in Atlanta, Georgia, with offices in Mobile, Alabama, and in Orlando and Tampa, Florida, CERM has a staff of over 100 professionals committed to delivering innovative client-centered environmental consulting services. Founded in 1995, we are celebrating our 25th year of service with a mission to empower our clients, associates, partners, and community through the disciplined application of integrity, initiative, loyalty, and sustainability. From environmental due diligence and remediation efforts to water and sewer infrastructure and civil site design and construction, we see each project as an opportunity to rebuild and improve communities. We thank you for this opportunity to sponsor, and without further ado, we'd like to present you a short video.
Corporate environmental risk management is a full-service environmental, energy, facilities, transportation, and water resources firm that aligns human, technology, and capital resources for the AEC industry. Over the past 25 years, our small minority-owned DBE firm has grown to more than 100 technicians and professionals. Our civil engineers, environmental scientists, surveyors, and project managers support projects of varying scope and scale for our clients. Our team has broad-based experience covering several key practice areas, including program management, construction management and inspections, environmental and remediation services, civil design, survey, and geotechnical engineering. We provide these professional and technical services to our energy, environmental, federal, facilities, and water resources clients across the southeastern United States. When it comes to environmental services, CERM brings considerable know-how and commitment to environmental challenges unique to these types of projects. We routinely work with school systems, national, regional, and local governments, and corporate stakeholders to provide a range of environmental services. These services include sustainability, compliance, assessment, and remediation. Further, we understand the unique responsibilities and risks associated with environmental restoration and remediation projects. When it comes to navigating the complexity of an environmental project, CERM's demonstrated regulatory expertise ranges from single-site evaluations to federal impact studies, allowing CERM to handle any size project. Whether it is an EPA project, brownfields assessment, or regulatory support, CERM has the team and the capabilities to support you through the whole process. Today, more than ever before, environmental impacts are linked to economic development, regulatory partnering, community planning, and public policy. With the depth and breadth of our expertise and our hands-on experience with large and small environmental projects, CERM is a proven leader in environmental management. CERM is more than just an assessment firm. We have a deep technical bench strength that provides special services beyond just providing environmental assessments. Our team has the ability to manage projects from the planning phase through closeout. Corporate Environmental Risk Management is your single source for environmental service needs.
Okay, thank you. Our two speakers this morning are Matt Jones and Adam Driggers. Matt is the Director of Reliability and Mechanical Integrity, and he is in his second year with Hargrove. He spent the majority of the last decade in various functions, including maintenance leadership, reliability engineering, predictive analytics, and capital projects. His industrial experience includes refining, chemicals, and pulp and paper. He is a graduate of Mississippi State University with a BS in Biomedical Engineering and a master's degree in Mechanical Engineering with a focus in materials science. Adam Driggers has been with Hargrove since 2014 and is the Director of Surveying and Scanning Services. Adam graduated from Troy University with a bachelor's degree in Geomatics. He's a professional land surveyor in Alabama, Florida, Georgia, Louisiana, and Mississippi. He has 17 plus years in surveying and dimensional data capture with experience in traditional land surveying, offshore deep water positioning, 3D laser scanning, and drone data capture. And with that, I'm going to turn the meeting over to Matt.
All right, thank you very much, Ellen. So we're going to get our presentation pulled up here. We'll run through it. We want to take a little bit of a different approach than what may have been done in the past. Are y'all able to see my screen?
Yes, we can see it.
Okay, great. Yeah, so what we wanted to take some time to talk to you about today, and I appreciate the introduction, is really, when we think about basically the environmental approach, the environmental industry, some of the big impacts we can have are really around we have to take care of our assets, and so that's what we want to talk to you a little bit about today, and some of the tools and technology that's out there to really help with that. So before we do that, I want to we have a quick safety topic. Every week at Hargrove, we have a different safety topic, and one of the things we want to talk about today was chemical safety in residences, and Ab and I were both talking. We both have kids at our homes, and this is a really critical thing for parents to keep in mind. It's there are so many different chemicals, and we kind of take it for granted as adults, and we've been cleaning and doing all this kind of stuff for years, and we know that when you have to think about it from a kid's perspective or a pet or anything that really doesn't understand the consequences of what could happen, it's so critical that we keep these things contained and secure. And also on the disposal side, disposal is a very key part of chemical safety, especially in residential areas, because there are consequences, unfortunately, when it's not done properly. All right. So we want to first couple of things we're going to talk about are just some past environmental disasters, environmental issues that have taken place and really jump into some root causes and kind of try to bring a commonality to some of this. So first is the Boston Molasses spill, and one of our teammates, when we were putting this together, actually Alan told us that he'd actually been here, and this kind of started a lot of the ASME codes. But what happened whenever during World War I, the construction process was rushed for this tank that was in Boston, and it was interesting. Just a few years later, all the different the neighborhoods around it and all the different residences, they got accustomed to hearing this large tank just groan and leak, and they actually used to send kids out there with pails to get molasses from the leaks in the tank, believe it or not. And one thing we know about cracks is if they're not mitigated, they could just continue to spread until it's catastrophic, and essentially that's what happened. And it failed, and it sent molasses waves 15 feet high through the area, and that's one of the things that I can't wrap my head around, the 15-foot high wave of molasses at 35 miles an hour. And unfortunately, there were over 20 people killed in this incident and 150 injuries. Due to the rust construction, the poor maintenance practices, they weren't monitoring. There were no practices back then that really would lead to, coming in and checking on the tank and looking for cracks and mitigating that. It was a different time, and we didn't have the knowledge then that we do now. And so you think about this incident, and it really helped generate the conversation, was a catalyst for a lot of the codes that we see in ASME currently. Next, we have this was in 2008. There was an ash pond, a levee failure in Tennessee, and this was and unfortunately, there's a lot. Pond levees and dams are something that often go unnoticed or not given the attention that they deserve, because it's there. We build it, it's there, and if we see it leak, we'll try to do something about it. When in actuality, there's a lot more things we can do to monitor levees and dams. In this situation, it was a coal plant, coal power plant that byproduct of burning coal is ash, and it was sluiced to an ash pond, which is a typical technology, a typical process for getting rid of ash, where it's settled out and then you dredge it and store it. And unfortunately, 3 of the 4 dredge cells failed, and we had about 5.4 million cubic yards getting to the native waterways around there. And that's an unfortunate situation. You see here from the photo on the right that there was residences, there was a large impact downstream, unfortunately. And again, it was a result of not truly understanding the assets. And we think, in the manufacturing world, we think of assets as pumps and tanks and reactors and that type of thing. But levees, pond dams are all every bit of an asset to us that we have to track and maintain. Here we had 60 different lawsuits that were filed, and the facility had to buy nearly 180 properties around it. So quite, and the company or the organization's still going through a lot of headache, and this was 12 years ago. So these things never really linger, and it's hard to get out from behind these types of incidents when they happen. It's hard to put a presentation. Is that right?
Still showing it.
Let's see. All right, there we go. So, sorry, I think we may have lost our presentation there for a second. Of course, so when we think back to the root causes of this one, it was improper maintenance. It was the critical tools and technologies that we have available to us to measure dams, whether it's inclinometers, doing different soil samples, boring, and then when we expanded, I say we weren't involved in this one, but when the expansions did, when the vertical expansions took place at the site, a lot of the design, there were some of the root causes where the designs weren't properly vetted and executed. So when you think about the design applications of this plus the maintenance side of it, the topic of this is strategic asset management in environmental applications. And the asset management piece you're going to see the common theme and you have on these two, and you will on the next one as well. Let's see, going to the next one. So the last one we want to talk about here, and unfortunately, you could spend all day talking about some of the past disasters, past environmental disasters, and we're not going to get into that but this is the last one I really want to cover. This was in Russia. This was actually this year. It was a diesel fuel tank rupture that was. It's similar to the molasses thing, and you think we learned from our past sins. Well, the similar situation. It was in a nearby residence, and some of the residents had noticed that it had began to leak, and it was just kind of expected, and lo and behold, it turned into a catastrophic failure. And unfortunately, 31,000 cubic meters had to be removed, and they're still working on it. It's $145 million in cleanup efforts to date, and again, it's we think about the financial burden of this, but really that is the least of the concern when you think about what's happening, what's transpiring to nature, to wildlife, and then you have the public perception. There's a huge distrust there when these types of things happen. So we wanted to talk to you a little bit about these past failures to show the common theme of when we're not adequately monitoring assets, when we're not looking at levees, tanks, piping. I mean, there's so many things that we have codes, we have these things available to us, and it's so important that we truly dip into and take advantage of what's available to us now, some of the codes and technology. And so when we think about reliability excellence, when we think about asset management, this is somewhat of an industrial standard reliability pyramid. I've done my tweaks based on my experience with it to it. But when we think about why it's so important to have proper asset management, and because what we want is predictability and consistency. That's the bottom line. We want predictability and consistency, because what that does, that leads to improved environmental health and safety, of course, as we've seen here, that when we know our assets are in good shape, we don't have to worry about this type of thing happening. And we're also much more effective. We're much more productive. Our OEE goes up. We're all more successful overall in the end. And one of the things that I can't stress enough, and it's the from this slide, is even the smallest, and I'm going to read this because I truly believe it, even the smallest and most basic assets must have a reliability plan. And because whether it's a small piece of pipe, it's a small tank, it doesn't take much to result in a catastrophic failure, because you never know what's upstream, downstream, and how the dominoes are going to fall for a piece of equipment. So when we think about the environmental side of this, that whole pyramid doesn't necessarily, it's an asset management roadmap in manufacturing. But when we think about just the basics and how this applies to the environmental applications, you have to keep equipment history. You have to understand the criticality, mechanical integrity for pipes and tanks, just like we covered. We have to look at our key performance indicators, KPIs, and there has to be checks. There has to be preventative and predictive maintenance strategies applied to all these assets. And this is just a couple of things I wanted to highlight based upon this pyramid and how it applies to what we're talking about today. So when we think about some of the tools and topics that are available to us, we have to understand, one, why we're talking about this, how it really comes into play. And you see on the little graph on your right, this is what's known as the P to F curve. So in asset management, the P to F, P means precision, all the way to F in failure. And so the whole goal is to keep everything in a precision state, just like if it was just a new pump and motor put in, a new tank put in, a new pond built. We want to keep everything in that precision state, because as it starts to fail, the cost of ownership really, really grows, and it takes so much to remediate it, so much effort, headache, manpower, and the phone hardly ever quits ringing when you get to that point. So we have to put all the things today are to keep us in this precision state. So we're predictable and we're consistent. So a few of the things we have, some of the tools at our disposal nowadays in industry and with our reliability effort, we have to make sure we're doing the proper preventive and predictive maintenance. And whether on a tank, that's looking at wall thickness, you're looking at crack propagation with rotating equipment, you're looking at rotating equipment or transformers, you're looking at oil sampling and testing, rotating equipment vibration analysis. Nowadays, we have predictive analytics with artificial intelligence, where we have the technology nowadays to monitor assets much more finely and keep us up in the green region of this P to F curve than we ever thought possible. And we also think about the precision maintenance and the QA/QC whenever we're going through construction, whenever we're going through installation. We have to make sure that everything is left, or when it's turned over and we're started up, we're in a precision state. And we have the documentation to show that, because if an asset does start to fail, we need to be able to go back and understand the state we left it in and how it got to where it is when you go through the root cause analysis and determine levels of repair. And just on some of the disciplinary side, a lot of this falls on mechanical, electrical, civil structure when we talk about a lot of the pond levees, building, and stuff like that. So every engineering discipline has a play at this, and especially on the environmental side. So, and when we think about how we want to care for equipment, how we want to inspect, one of the things that we use nowadays, as you see on the video here, is drones. Drones are, and I don't want to talk too much because that's this guy's expertise right here, When we think about looking at mechanical integrity, there's so many more tools available to us now that that we really need to be utilizing, because one, they save money, they save time, lost production. You know, you think about the inside of this furnace right here that we're looking at. They didn't have to spend a full shift or two scaffolding this furnace. They didn't have to even clear it for confined space. The drone in there, and you look at this. But also, and not to get too deep into the drone, because I know Adam's going to talk to you a little bit more about that. But we have to have good record retention, data management on this, because that's absolutely critical for compliance and understanding where our assets are in their state, and looking at that P to F curve overall. Also, pipelines, corrosion under insulation is a big one. You see a lot of pipes in different various manufacturing settings that are insulated. Well, unfortunately, water can get under that insulation, and you don't know the pipe is corroding until you peel it back, or either it fails. So it's very important, and there's so many of these codes that are available to us that it's just so critical we understand and apply to the different avenues and the different aspects of our role in manufacturing. And so I'm going to segue, and I'm going to let Adam take this, and we're going to talk a little bit more into our tools and technology we have available to us.
Yeah, as Matt just mentioned, you know, one of the tools that are out there that's got multitude of uses are drones. As you just saw in the previous video, putting a drone into environments that are hazardous takes out the human element. So there's a safety factor there, that you can send that piece of equipment in. You don't have to send any personnel in, and you don't have to consider any confined space, you know, putting people in those hazardous environments. So from a safety standpoint, drones are key. And there's several different uses that are out there for a drone. Most of the time, you've got cameras mounted on the drones for either video or still imagery. That data capture is done by just taking pictures or just turning the video on and recording the video that can be live fed. You can see it on the screen as you fly the drone, or store it, have a record of it. You know, if you're doing annual inspections, you can keep all that data. It's electronic. I mentioned the safety aspect of it. You know, drones can go into areas that are more difficult to reach than others, and get much safer and better vantage point. Some of the camera payloads that are out there now have extremely high resolution cameras that, you know, can get close up. You do an inspection, the drone can be sit back a little bit, you can zoom in, get very high quality imagery that you wouldn't be able to get say if you were taking pictures from the ground just walking through an area. You can get different vantage points. Drones can also be used for mapping existing site conditions for hazard assessment, taking that imagery and converting it into mapping quality data, which can then, you know, be turned into 3D point clouds or ortho photos of an entire site. Allows for planning for any hazard assessment types of conditions. There are thermal camera payloads that can be put on drones to detect hot spots. You know, if you've got, you know, exterior furnace or a kiln and a paper mill that may be having hot spots due to wear, you can take the drone, take some pictures with the thermal camera, and see where those hot spots are. You know, couple of the previous environmental disaster slides mentioned levees failing. Thermal cameras can also be used for levee and dam inspection. If you've got leaks, your water temperature, you know, if it's seeping through, is going to give a different temperature signature than your soil or your concrete around it. So to help identify where those problem areas could be. Leak detection. There are camera payloads for drones that can detect certain types of gas leaks. Usually those are carbon-based gases, but different cameras can detect different types of gases. So again, safety aspect, you don't have to build scaffolding in the area in a pipe rack and put people in harm's way trying to find a leak. You know, have a drone, keep people far away, you fly the area, and be able to determine where those are. And like I mentioned before, it's able to provide immediate feedback. You can see it, on the screen as you're flying. So, next slide. Here's a little animation of, I mentioned taking the data and combining it for site hazard assessment. This particular one, where are your critical areas that may be in low spots if you've got any issues with flooding. You can take that data and marry it up with where your water surface elevations would be at certain points and figure out, all right, well, this area is more prone to flood. These are low spots. It can help in assessing a site, determining, if an emergency happened, or what impacts of your infrastructure that would, be affected by a flood. What would happen to that equipment? Would something fail that would, due to flooding, that would cause some sort of environmental impact? Next one. Another tool that's out there, not only with a drone, but laser scanning and 3D data capture, collecting information and putting it into a 3D environment, not only to identify, where or any potential issues that exist, for example, for tanks, you might have distorting or around this. These tools are available that can be taken of an area and determine, are there any issues with the integrity of that asset. The data is digital, which I know the last several months with dealing with COVID and working from home, being able to capture that information and put it in a digital format that can be shared either across a network or transferred via hard drive, makes it a lot easier and for all of us who need to keep doing our jobs, whether that's in the office or from home. The data can be used just about anywhere. It's highly accurate, and higher. It ensures your equipment effectiveness and reduces the chance of failure. And not only identifying stuff after the fact, but also aiding during the construction, to ensure that equipment was properly fabricated, to the design, that everything will fit up as it's installed in the field to make sure that it does properly function. If you've got some stresses that were not intended to be there during the design, say you've got a pipe that was fabricated incorrectly and they try to, shove it in and make the bolts line up, well, that adds stress to that piece of pipe or that piece of equipment it's connecting to, which would cause wear sooner than anticipated. So you may have a failure earlier than you thought, or it may require more maintenance due to issues because of that. So, these tools are out there that can help take those measurements, and a lot can be done with some 3D points. So.
Yeah, and one of the things this makes me think about, especially as we're now in our pandemic state, is you're able to walk through a site, able to walk through a facility from your laptop. If you're working from your house, your office, you're walking through and you're seeing data that was there, that may have been taken with a few months ago. So as you're planning for an outage, for a turnaround, as you're scaling up for a capital project, whatever it is, you're not only during a pandemic are we able to work remotely, but you're also able to, even when you think about the future, as we get back to a normal state, you think about the time it takes to get a PPE on, get the shuttle, go walk around the site, get the contractors together, go check in at the control rooms and all that other stuff. You have this right here at your fingertips. And it's such an advantage nowadays that we have these tools of technology. That's really, it is the future. And we've seen that drastically increase since about March when everybody started to hunker down. So, and a couple more things we want to talk about. One is computational mechanics. So you see there's a little video clip up top. This was we did an analysis for an expansion joint failure, and this is a completely modeled, this through ANSYS. This is a finite element CFD simulation up here. What we're able to do is we're able to take problems that clients have, whether it's the failing of miscellaneous assets, it's when you actually have the inspections done and you see that we caught some thinning somewhere. We've had some wear, some corrosion, and our tank is thinned out. Well, that doesn't mean you have to replace it. That means that we need to do a deeper dive. We need to do a fitness for service test, because oftentimes we're able to give 5, 10 more years out of a tank just by making a few modifications to it, strengthening it up. Because we hit certain checks within our mechanical integrity inspections does not automatically mean replace. And I can't stress that enough, is that we're talking extending, reducing CapEx, and pushing some of that out where you can focus on your much higher priorities. And the thing is, it's just this type of technology, it's not well known, so we struggle sometimes to make sure we leverage it and take advantage of it. We also think about, with CFD, if we're computational fluid dynamics, just like this little clip you see up here, whether that's water hammer, that's, there's so many things. This was a $750,000 failure at this point, and we went and did a study, and for pennies on the dollar, we were able to just put a different style valve in for them and reduce the failure that had happened 3 times before. So it's these simple things that are available to us that we have to just make sure we continue to take advantage of. When we think about the computational mechanics, this is going back to what we're seeing. So all these different type of damage mechanisms that we have to keep in front of us, because these small things can get pretty big quickly. Just like the tank we mentioned, both tanks actually that were talked about earlier in the presentation. You see these cracks here, these fatigue cracks, these crack-like flaws. Those can grow quickly. I mean, because of some of the very stressful processes we put these assets through, all these things have to be very carefully monitored and mitigated as applicable. This is one of the examples about the tank that I was telling you about, actually. So here we were able to make a grid of the vessel. We found our T-min here in this specific location, as you can see through the discoloration here. We put some remediation bands into it and gave it 10 more years. Instead of spending $3 million on a new tank just for pennies on the dollar, here we go. We give you 10 more years out of it. Pipe stress analysis is another one. Leaking pipes lead to leaks. Vibrating pipes lead to leaks, and that's one of the unfortunate things. And very few things we have running through pipes in industrial manufacturing are okay to hit the ground. So it's so critical, whether it's flanged or welded pipe, that any type of vibration be addressed sooner rather than later, because it will leak. When you think about the fracture mechanics, when you think about fatigue, vibration, it will leak. So EPD, electrical power distribution, is a big part of this. When we think about all the different control systems that are put in place, when all that requires electricity, and of course, we design for fail-safe. We design to lose it, but whenever we start to lose electricity, we start to lose our controls, we feel harmless at that point. We kind of are. So that's why it's so critical that we also understand our switch gear, understand anything inside your MCCs, your cabling, your electrical integrity, electrical instrumentation integrity is often understated, and it's so critical for our well-being and our success in manufacturing. I touched to this just a little bit earlier, predictive asset monitoring. So through AspenTech, we're able to look at, and this is the only MTEL application. This is a software that monitors all the data coming in and out of an asset. And nowadays we have so much data. We think about Internet of Things. We think about everything that's available to us. Well, we struggle. Now we're to a point where we're kind of data overload. We struggle to understand exactly what's coming in, because not only are we trying to look at all the data that's in front of us, we'll also be pulled into 15 different things trying to fulfill our roles that are in front of us. So when we think about the future of manufacturing, we think about cutting edge technology, this is what we're seeing as far as asset monitoring goes. This is able to detect failures early on before you even see bearing patterns, before you start to see any type of vibration, and this will work with operators, work with your operations group to make sure that you're operating and maintaining as you should be to maximize life throughout the asset. And the last slide we have is on RAM modeling. So this is the theory on RAM modeling, is we're able to basically give you extra dimensions to your design and your facilities. And the way this ties in, so what we're doing is we're looking at the full throughput, and what we do here, when you think about a design, you think about everything on paper. This adds layers of time and reliability, predictability. So we're not only we're basically taking our drawings and our process design, we're running it through life cycles. We're understanding exactly when the failures might occur, when we're trying to schedule turnarounds. We were trying to push turnarounds to 6 years. Okay, so what's that going to take? And what this does is this allows us to quantify and predict our failure patterns so we can design around that. If we're trying to hit a 5-year turnaround and this pump that we're putting in, we understand, history tells us it's only a 4.5-year life pump before it, have to start having seal failures, something like that. So we have to put in some redundancy. And so this program really allows us to dig deeper and add those layers of technology, those layers of design, take it into reliability, take it into life cycle approach, so that we're able to understand those true concepts and design and safely design to where we can mitigate any failures that would result in any environmental catastrophes. And with that's our last slide we want to talk to you all about today. I hope this gave you a little bit of an insight to asset monitoring and how critical it is until it really how we are successful, how we mitigate environmental risk, because it is critical, and the two are often thought of independently when in reality they're not. Jennifer, thank you very much.
Great, thank you. This was very interesting, Matt, Adam. I really appreciate your taking do this. Do we have any questions? If y'all, I don't see any that came through the chat, but we have time, plenty of time, if anyone wants to turn on their mic or their camera and ask Adam, Matt some questions.
While we're waiting for folks to type their questions, this is Helen from Avonic, and Avonic, we have a drone, and we love it. And it's just what you're saying. It is so handy, and you can get there fast, and you can see from above. And it has the minute we started using it, people were saying how much better their decision making is, especially in the beginning of a situation. So yeah, I can't endorse it enough.
Yeah, that's a good point, Helen, when it comes to decision making, because we're able to, in very quick time, see any type of hot spots, see where, Adam talked to the pond and the dams and levee situation, being able to understand the different temperature contrast if we do get to experience leaks. And unfortunately it happens, but we just got to jump out in front of it when we see it, and that helps us monitor it so much more quickly.
Mm-hmm.
Does anybody else have any questions? Well, I just want to say thank you again to Matt and Adam, and thanks to the Hargrove team who always help us with making sure we don't have any technical difficulties with the meeting. So Daniel and Tommy, thank you. And thank you to our sponsor, CERM. We really appreciate you sponsoring this event. We will, and to Dr. Gibbs for being here today to share with us about the company. So if no one has any questions, then I will just say, have a very happy Thanksgiving next week, and I hope to see you all at our seminar on December 3rd. So y'all take care and have a great day.